Good morning. In this lecture series, we see about biomechatronics. So in this class, we discussing about what is a biosensor and where is the using for the mechatronics applications. So let's discussing the topic. So first of all, what is the biosensor and transducer? So when you are to introducing the sensors in a biological manner, okay. So we have to diagnose the following what is the domain we have to use using for that. So the one is the modern diagnosed environmental monitoring, healthcare, and food safety, and the environmental science. Okay, so these are the main important domain we have to using the biosensor and transducer. So the transducer's main application is we have to convert the what kind of application I want to do that. Okay, that is the purpose of the transducer. So this is my empathy of this lecture series. Okay, so what we have to going for the where we have to apply the biosensors and the biosensors we have to using the where is the application, that is my one of the main major role for this. So when introducing the biosensor, okay, so the basic definitions, so are the component of these sensors and the application of the biosensors. So when going for the biosensors, okay, so it can be classified as a recording the brain electrical activity. So this system we have to converting the like a biosignal from the EEG. Okay, so and it's accessing the muscles and the electricity activity. Okay, so this will be controlling the electrical biological signal of EMG, and this will be measuring the heart electrical activity, and this will be using for the ECG. So these are the terminology we have to using for the different types of applications. Okay, so when we are to going for the recording the brain, we have to move for the ECG, and is measure the heartbeat, we have to go for the ECG. Okay, so these are the signals we have to identify the what kind of what is kind of my role we have to doing for that. Okay, so that is the main important role for we doing for the biosensors. And mostly we have two types of transducer. So I have to find out the application of the biosensor, but I have to convert this with motions. Okay, so that's why I am choosing that. So here the three types major we have to classify that. So the one is electrochemical transducer and optical transducer and the piezoelectrical transducer. So in coming for the electrical transducer, electrochemical transducer, so one of the main sensitivity on the specificity, okay, and also the optical transducers is can be utilized the light interaction. These transducer measure the light absorptions. So the piezoelectric transducers is a mass sensing and detecting the mass changes at the new molecular levels. So these are the types of transducer we have to using for that. So what is the main application and working of the biotransducer? So the one is the bioreagical element. So we have to choosing the component that will be interact the specifically with the target analytic like animizing and antibodies. So the single transfection must make sense. We have to conversions of the bioreceptor and binding the interaction to the measurable signals. And also the data processing and output, the producing the signal lead to the digital display for the analyze and the decision making. So these are the working principle of the biosensors. So here we have to classify the major steps. We have to the final outcome we can be processed. Okay, so that outcome can be where is coming from this, that is the data processing. The data processing is can be give the signal. Okay, how the mechanism I have to work is, that is so the signal translations it can be using. So that type of transducer we have to choosing the types of transducer is based upon your application and what kind of mechanism I have to doing for this. Okay, so and also the biorecognition element. So if I'm going for the ECG or EEG, okay, what kind of signal I have to transmit, what kind of signal I have to extract from the that is the object. So that is the main component of the biosensors and is also transducers. So what are the advantages of the biosensors? So we have to important that the one is the rapid detection and the high sensitivity and the specificity and the portability and the easy usage. So let's discussing the rapid detection. So like a testing and real-time monitoring application. So these are the rapid detections of the our human body. So on the human sensitivity and the specificity is here, concentration of analysis and the biotraptor and target molecules. So the portability and the easy of usage. The many biosensors are designed to be compact and user friendly. So based upon that, we have to using uncomfortable takedown gun. We have to measure the heartbeat or a pressure, whatever we have to measure the pressure for the those things of concept. Okay. So then let's summary of the our lecture series. The biosensor and transducer, the mainly the classify as the three signals. The one is a role in diagnosis and the function and the applications. So when going for the functions, we move for the function orienters. Okay, so that converting the biosignals and the functions can be transferred into measurable data, and the functions can be transferred into the facilitate the rapid analysis. So and also the final is they facilitate the accurate analysis. The role in diagnosis, the environment monitoring, and the modern diagnostic and different technologies we have to introduce this. So the biosensor and transducer main component we are using for the mechatronics application. By using of the mechatronics application, we have to introducing the biological system. We have to measure the signals from the human cells. Okay, so that's why we have to give the correct treatment we have to given for that. Okay, so this is the final series of the biosensors and transducers. Thank you.